This is Algebra 1, Section 3.2. We're solving one-step equations using multiplication and division beginning on page 138. Couple goals with solving linear equations with multiplication and division, and we're using those to solve problems. So properties of equality, we have a couple definitions. The first one says the rules of algebra used to transform equations into equivalent equations. We talked about solution steps on the last section. Properties are the things that allow us to use solution steps. Um, and we'll talk more about what the properties are in just a second. We also did ratios when we talked about probability and odds. The ratio of A to B says if A and B are two quantities, so there's two different values probably, measured in the same units, so units talking about inches or pounds or uh, any unit that you're talking about, then the ratio of A to B is written as A over B, just like that. So A to B, so the ratio, just if we just plug in two different values, let's say the ratio of 2 to 3 is the same thing as 2 to 3. That's all it's saying. Then we have similar triangles. Draw yourself two triangles that go along with this one. I know that it's not part of the definition. It's not part of the picture. But they have equal corresponding angles. The symbol for similar, anytime you see like a little wavy symbol like that, that means similar. Similar, all that means is same shape. And you'll look more at that when you get into your geometry class. We'll expose you to a few things to where you're ready for when you get there. It says they have um, equal corresponding angles. That word corresponding just means it's in the same position. So we know that this is the angle that's at the top of the triangles as we're looking at them, and that's the one that's at the top of that triangle. So those two would be considered in the same position. They have the same value in their angle. So let's say, for example, that the value of this one was 48 degrees. Again, I'm just making up a value to go along with it. If these were similar triangles, then this other one that's in the same position at the top would also be 48 degrees. The same thing would be true with the ones that look like right angles. They would have the same value, and the same thing would be true with the ones that are in corresponding positions on the bottom right. They would have the same values. But similar triangles have the same values in all of those angles. Here's some transformations that produce equivalent equations. It says the original equation says x over 2 equals 3. We can also read that as x divided by 2. We know to undo division, you multiply. Just like last week, we talked about you undo addition with subtraction and you undo subtraction with addition. This week, you undo multiplication with division and you do likewise, you undo division with multiplication. This one says x divided by 2, so undo divide by 2 by multiplying by 2. When you multiply this side, it'll cancel it out, but you have to do the same thing to the other side because you have to make sure you balance it out. So 3 times 2 gives you 6. The same thing's true with this one. It says 4 times x. Undo 4 times something by dividing by 4. You do the left by 4, you have to divide the right by 4 as well. You divide the right by 4 as well, and when you divide 12 by 4, you get 3. So x is 3. Example number 1 says solve 8x is equal to negative 3. It says on the left side of the equation, x is being multiplied by 8. To isolate x, you need to undo multiplication, and the inverse of undoing multiplication, or the inverse of multiplication, is to divide by 8. So we have 8x equals negative 3. Divide the left by 8, and what that'll do is it'll cancel out 8 divided by 8, and it'll just give you x. Divide the right side by 8 as well, and you're left with negative 3 over 8. There's no number that goes into both of them, so that's your simplified answer. X equals negative 3 over 8. Example 2 says multiplying each side of the equation. So the first one was to divide to undo multiplication. This one says x divided by negative 3. So undo divide by negative 3 by multiplying both by negative 3. The left side will cancel it out. When you multiply the right side by negative 3, you have 60 times negative 3. These two will cancel out on the left. And 60 times negative 3, we know 6 times 3 is 18. Just add a 0 at the end. And then a negative times a positive is a negative 180. So x equals negative 180. So again, cancel out multiplication by dividing. And example number 2, cancel out division by multiplying. Example 3 says multiplying each side by a reciprocal. All you're doing with this one is you're kind of skipping a step. Well, not really skipping it. You're just kind of speeding it up. If we were to read this right here, negative 3/4 m, we could say that that means negative 3/4 times m. So we know in order to undo times something, you divide. So what that would do is we would divide by negative 3/4. Dividing by negative 3/4 is the same thing. We know that in order to undo division, or in order to divide fractions, you multiply by its reciprocal. So dividing by negative 3/4 is the same exact thing as multiplying by negative 4/3, multiplying by its reciprocal. So all we're doing right here, instead of showing it in 2 steps, we're just skipping a step, or again, we're just speeding up a step. We're just multiplying by its reciprocal. So instead of dividing by negative 3/4, you just multiply by negative 3/4. You do the same thing to the right side. This is over 1. 4 times 15 gives you 60, and 3 times 1 is 3. When you divide negative 60 by 3, you get negative 20. So that's just multiplying by the reciprocal. Then here's your properties of equality. And we talked about 2 out of the 4 of these, but we've actually talked about all 4 of them. We're just officially defining them here. The addition property says that if A is equal to B, then when you add C to A, it's the same thing as adding C to B. Same thing with subtraction. If A is equal to B, when you subtract C from A, it's the same exact thing, or it's equal to subtracting C away from B. So here's the first definition of multiplication property of addition. Again, just like the first 2, if A is equal to B, then multiplying C times A is the same thing as multiplying C times B. And likewise, the division property says if A is the same as B and C is not 0, and the only reason that changes to not 0 is because you can't divide anything by 0. It makes it something that doesn't work. But A divided by C is the same thing as B divided by C. And here's the checkpoint right here. It says 9x is equal to 72. That's the same thing as 9 times something. So undo multiply by 9 by dividing by 9. If you do it on the left side, you have to do likewise to the right. It'll cancel out on the left and just leave you with x. And 72 divided by 9 is the number 8. We can justify that solution step. All we did was 1 step. We can justify it by saying we did the inverse of multiplication, or we just undid multiplication. 4 equals 11 times m. This is just like the last one, except the m is on the right side, or the variable is on the right side instead of being on the left. Undo multiply by 11 by dividing by 11. Do the same thing to the left side. It'll cancel out on the right and just leave you with m. And there's no number that goes into both 4 and 11, so m is going to stay just like that. It equals 4/11. You can follow the same exact justification and say it's the inverse of multiplication again. 3 says y over negative 6 equals negative 15. Over something is the same thing as divide by something. So y divided by negative 6 means y over negative 6 means y divided by negative 6. In order to cancel out divide by negative 6, multiply by negative 6. That undoes it. If you do the left by negative 6, you have to multiply the right by negative 6. We know a negative times a negative is going to give us a positive. It'll cancel out on the left for us and leaves us with just y. And negative times negative is positive. We know that 15 and 15 is 30, so you have to do that 3 times. So you wind up with the number 90. So y, I said 90, I wrote 30. Y equals 90. Again, just 1 step. And unlike the last one, this one is the inverse. Not of multiplication this time, but the inverse of division. Or we undid division. 4 says negative 5 over 2 equals n over 2. Again, n over 2 is the same thing as n divided by 2. So in order to undo divide by 2, multiply the right by 2. If you do that to the right, you have to do likewise to the left. If you multiply straight across, 2 times negative 5 is negative 10, and negative 10 divided by 2 is negative 5. So these will cancel on the right. N's value equals negative 5. Again, only one step, and it is the inverse. We'll shorten it up a little bit right here. Inverse of division. Negative 2 over 9b equals 18. So this is one we're going to speed up a little bit. And it says negative 2 over 9 times b. Instead of dividing it by negative 2 over 9, all we're going to do is we're going to multiply by its reciprocal. So negative 2 over 9 times b equals 18. Undo negative 2 over 9 times something by multiplying by its reciprocal, negative 9 over 2. Again, it doesn't matter where you put the negative. If you do that to the left side, you have to multiply the right by the exact same thing to keep it balanced. It'll cancel it for you on the left. This will cancel this, and this will cancel this. And the only thing that you're left with is b, which is what you were looking for. Everything's considered over 1. We can cancel out 18. The number 2 goes into itself 1 time and into 18 9 times. So 9 times negative 9 is negative 81. And what we did right there was the inverse. Believe it or not, even though we multiplied, this is the inverse of multiplication. And the reason that we multiplied was because we were undoing multiplication by dividing, and we just sped up one step and said instead of dividing it, we just multiplied by the reciprocal. You do likewise with number 6. 3 over 35 equals 2 over 5a. So 3 over 35 equals 2/5 times a. Instead of dividing by 2/5, multiply by its reciprocal. So multiply by 5 over 2. If you do the right side by that, you have to do the exact same thing to the left side. It'll cancel for you. 2 will cancel 2, and 5 will cancel 5. So you're left with just a on the right. That's what you were looking for. The number 5 goes into both 5 and 35, into itself once, and into 35 7 times. So now we're looking with smaller numbers. Go straight across. 1 times 3 is 3, and 2 times 7 is the number 14. Again, just like the last one, the way we can justify this, we can say it's the inverse of multiplication.